Any questions? What's everybody doing? All right. Mm-hmm. The square root? Uh-huh. Oh, wait, hold on. Got it. Square root 3 to the second power, like that? All right. So what am I doing with that? Just answer it?
So, yeah, so I'm thinking, like, what number?
Mhm.
Now,
So you write 3 squared is the square root of 9, right? And the square root of 9 is what? Just 3, right? That's it. Yeah. So you just shortcut, cancel these out, write 3. That's it. Oh, yeah. What's up? Plus or minus 169, all right? What's the square root of 169? All right, so it's just plus or minus 13. That's it. Yeah, that's 2 answers. Yeah. Positive 13, negative 13. You don't, you just put it separate, like positive 13 and then like comma, negative 13. Yeah. Like positive 13 and then comma, negative 13, something like that. Yeah. Mhm. Mhm. How about you guys? Y'all good with homework and stuff? That's correct? Incorrect? Switch it around. Negative 13, positive 13. We're good? Oh, go ahead. Negative what? Like this? All right. So it's a little bit more complicated now, right? So I need to know what is the largest perfect square that goes into 90. So what is that? What is it? 49? Oh, 9 and 10? All right, I got you. 9 times 9 is 81, yeah. Yeah, but not this one. This is 90 at 1. Got you. And then this becomes what? Negative square root 9, square root 10. Oh, what's the square root of 9 again? I forgot. 3, right? So negative 3 square root 10. So that's how you do that one. Let me see. Let me see. Comma, not plus, comma. I try comma. Yeah. So like negative 13, comma 13. Yeah.
you remember the first answer?
Question? Which one was it? I'm forgetting.
It was like 3 numbers before I had
Oh yeah. Yeah. Yo, greatest common factor. That's it. Yeah. I didn't do it, but like yeah. Yeah. Nah, no AC. Straight up, just greatest common factor because it couldn't be factored by the AC. It wasn't factorable. Yeah. So just the greatest common factor. And that was it. Yeah. To be honest with you, I made that joint in like I don't even know like 15 minutes before class, so I didn't even have a chance to check anything. Like it was just copy and paste, you know. What's up? Wait, say it again. Cube root like that, and then what? 216. All right, that's a doozy. So what's the largest perfect cube that goes into 216? 6? 6 times what? Oh, what is that? Oh, it is? Okay. So I heard someone say it was 6 to the third power. So you already know what's gonna happen in that. He's gonna cancel out. It's just 6. Hmm. That's not bad. Go ahead. 2 over 5x like this. Okay. Plus what? 5. That's it. All right. So I'm guessing what they want us to do is simplify this, right? So to simplify this is two rational expressions, right, that we're adding together. We have to have the same denominator, right? We want the LCD. So what's the LCD here? 5x squared. Very good, right? That's our LCD, right? So what am I going to multiply by this 5x squared here? 1. What I do to the bottom, I do to the top. Over here, I have x, right? But I want it to be 5x squared, right? So what do I have to multiply that by to get 5x squared? By 5, what? By 5x, right? But what I do to the bottom, I got to do to the top. So now what do I have? Look. Now 2 times 1 plus 5 times 5x, all divided by 5x squared. Let's do the math on that. What do I get? I get 2 25x over 5x squared. And then that's it. That's all you have to do. If you're typing that in, though, make sure you use the parentheses, though. Parentheses for the numerator, for the denominator. Yeah. So 3 cubed, 3 square root. It's like 3 square root. And what? That's true. That's true. But what's the real answer to this? Mhm. Anybody else? What's the answer to this? What's the answer to this? Hmm? What's the answer? The final answer? Yeah. No. So what is not real? That's it.
That's all I'm saying.
Yeah. That's it. Mhm. That's it. Hang on 1 second. So I'll put that on vibrate a little bit. All right, we good to go. We good to go. Not real. That's the cube roots. That's something different. So look, this is not the same thing as this. That's two different things. All right. This one is saying, the first one is saying 3 times the square root of negative 64. The second one is saying the cube root of negative 64. Completely different. All right. So what's the answer to the cube root of negative 64? Is what? No. Way too big. Yeah, what is it? Cube root of negative 64. 4? Close. -4. Now we're talking. All right. Remember, this is a odd index, right? So if I had -4, for example, to the third power, right? That would be what? -4 times -4 times -4, right? So this would be what? -4, -4, 16 times -4. Then you'd have the negative, what, 64 from that. Huh? Cube the square root? The cube root. Cube root, right. So let's go. If it was what? Fourth root. Mhm. And then 5 is fifth root, so and so on and so forth. Yeah. Hmm? This is called the index. I'm sorry? Exponent? Technically, it is an exponent. You're right. That's actually what we're doing today. But you're right. Technically, that is an exponent. Yeah. So that's the index. That's it. Anybody else questions? Go ahead. Okay, hold on. Wait, square root, like open like that? Like this? Oh, like this? Oh, got you. So this is square root -5 squared, like that. So what's the answer? Okay, so square root 25, and what's the answer to that? Good. That's it.
So yeah, that is exactly good. I don't know. So when the numbers in the outside,
Mm-hmm.
the minus
Right.
numbers inside.
Like it carries with it.
Yeah.
So if it was like this thing means square root -5 times -5. And then -5 times -5 is positive 25, right? And then you can say 5. Now, if it was like this, like that now, right? That would become square root, whoops, of -25. And then that one is not real. You know, so when it's on the inside in the parentheses, it gets carried out that many times. No? That's it. Okay. So you said fourth root of 256? Really? Let me see that. Negative. Did not mean to ask you that question. Okay. I gotta take a look at that. So what's the fourth root of 256? 4? Okay. So -4, and that's it. All right, let's jump into today's lesson. Okay. This is building off of what we did yesterday, so it's not too bad. But you know, before we jump into the lesson, I like to do a little blast from the past. So help me out with this. How do I do this? Real quick. Okay, how do I get the same denominator? So what's the LCD here? LCD is 3, no? $12 and 15. Okay, we could do it like that if you want. No, it has to be a number that both of them can go into. Yeah. 60 is the right answer. Yeah. Yes. Yeah, yeah. But we can we can use 12 and 15 if you want to. What do you want to do? All right. So if we're gonna use 12 and 15, right? What we're gonna do is I'm gonna multiply this 15 by 12. But what I do to the bottom, I gotta do to the top. Over here, I'm gonna multiply the 12 by the 15. But what I do to the bottom, I gotta do to the top. So remember, this is called finding a common denominator. This is not the least common denominator. This is a common denominator, right? So what that means is that when we get an answer, we're gonna have to reduce it at the end, right? So what do I have now? Now I have 7 times 12 plus 5 times 15 all over 15 times 12, right? Let's do the math on that, right? 7 times 12 is what? 84. Okay, so 84 plus 5 times 15 is what? 75. Very good. And when I add these together, what do I get? What is 84 plus 75? 159. Okay. Over to 15 times 12. All right. And then I have to reduce this, right? By how much, I'm not sure. It's probably gonna be by 3. I'm just guessing. I don't know. Let's see, 15 times 12, what's that? 15 times 12 is 60? 180, all right? I feel like this is gonna get divided by 3. What's making me say that is because if I take 1 and I add it to 5 and add it to 9, right? I'm just adding the top, right? 1 plus 5 plus 9, that's what? That's 6. That's 15, right? 15 is divisible by 3, so therefore 159 is divisible by 3, right? So what do I get? Like, what's 159 divided by 3? 53. And what's 180 divided by 3? 60. All right? And then that's it. Right. Because if we choose 60 now, come back up here, right? If I was to do 60 up here instead as my LCD, here's what would happen. So to change the 15 into 60, I have to multiply that by what? I think it's what, 4, I think, right? What I do to the bottom, I do to the top. To get the 12 to be 60, I have to multiply that by what? By 5, right? But what I do to the bottom, I gotta do to the top. So me doing that, what will I get out of that? This would be 7 times 4 plus 5 times 5, all divided by 60, right? So that's what? That's 7 to 7 is 14. That's 28 plus 25 over 60. Finish adding these together. What do I get? I have 53, I think. Yeah, over 60. But wait, that's the same answer I got here, right? But I just have to do that reduction at the end if I use the common denominator. Both approaches are right. Both approaches will get you full credit. All right. So whatever you like better, go right ahead and do. Help me out. Mm-hmm. What do I do with the power? Not add. True, when you raise a power to a power, you multiply. But what do I do with the power in the terms here? Close. I like that. I like that answer. Mm-mm. So what I'm trying to get you guys to say is that you're gonna apply the power to everybody, right? Um, Not really I guess kinda. It looks like distributing, but really I'm just kind of raising everything to the same power, right? All the characters in the term get raised to that power, right? Okay. So I heard 64. And then x to what? Nope. X to what? 6 power, right? Because whenever you raise a power to a power, you multiply, and then that's y to the 15 power, right? And that's it. Right? So whenever we raise a power to a power, we multiply, right? And then you put the power on everybody when it's outside. Right? Mhm. It's multiplying 4 by itself. So like 4 times 4 times 4. Right. Yeah. Yeah. All right. So now that we know that, help me out with this. What's the answer? Close. No, close. It's what? Not the hundreds place. No. What happens with negative exponents? No. But it's kind of related to what you're saying. It's what? Fraction, right? So this becomes what? Mm, close-ish. Right. It goes into the denominator and becomes positive, right? Like that, right? And then what's 5 to the third power? 125. So this is 1 over 125. So when you have a negative exponent, you put it into the denominator and make it positive, right? So boom, that's my answer. Questions on these? Good. So here's what we're getting into for today. We're going to simplify expressions with a raised to the 1 over n power, right? So rational exponents are another way of writing expressions with radicals. When we use rational exponents, we can apply the properties of exponents to simplify expressions. So the power property of exponents says that a to the m power raised to the n power is equal to a to the m times n power. So when m and n are whole numbers, let's assume we are now not limited to whole numbers. Blah, 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 right? Whenever you have a power and you raise it to another power, you multiply the powers. That's all that's saying, right? Suppose you want to find a number p such that 8 to the p power raised to the third power is equal to 8. We will use the power property of exponents, excuse me, to find the value of p. All right, let's take a look at that. That should be really interesting. All right, so multiply the exponents on the left, right? So we have 8 to the 8p raised to the third power. What are we gonna do? Multiply them together. So now we have 8 to the 3p power is equal to 8. Now we know just plain old 8 is what? 8 to the 1, right? So write the exponent 1 on the right. And now since they have the same base, right? We could set the exponents equal to one another, right? So since the bases are the same, the exponents must be equal. 3p is equal to 1. Solve for p. That's simple. Divide by 3 on both sides. Now you have p is equal to 1 over 3. So, right, 8 to the 1 over 3 power, then raised to the third power, is equal to plain old 8, right? But we also know that the cube root of 8 raised to the third power is also 8. So then it must be that 8 to the 1/3 power is equal to the cube root of 8. The same logic can be used for any positive integer exponent n to show that a to the 1 over n power is equal to the nth root of a. Really important, that formula. Write that down somewhere. That's our trick. That's our sauce right there. Mhm. So a to the 1 over n power is equal to the nth root of a. But I know at least one person fell asleep while I was saying that, so let me repeat myself. I know I like to do that. So rational exponent, a to the 1 over n power. If the nth root of a is a real number and n is greater than or equal to 2, then a to the 1 over n power is equal to the nth root of a. Make sense? Any questions? See, I know y'all lying. I know y'all lying. Right? Let's do this one more time. One more time. All right. So the denominator of the rational exponent is the index of the radical, right? There will be times when working with expressions will be easier if we use rational exponents and times when it will be easier if we use radicals. All right, in the first few examples, we'll practice converting expressions between the two notations, right? So let's take a look. All right, it's a fun little example right here. So if I have x to the half power, right? I want to write this as a radical expression, right? I want to write this as a radical expression. Oh, that was the wrong one. Okay, orange ain't bad. So let's take a look, right? So for a, right? I have x raised to the 1 over 2 power, right? I'm going to write that as a radical. So my denominator in the exponent's power is 2, right? So what does that mean? That means that this is going to be the square root of x to the 1 power. Just like that, right? Denominator is the index, right, of the radical. Let's look at b. I'm going to change my color up. For b, x to the 1 power, square root of x to the 1. Say it again? Yeah. Numerator goes on the radicand. Yeah. So y to the 1/3 power, right? Same thing, right? The denominator is the index, The numerator is going to go on to the radicand. So what is this? This is going to become the cube root of y to the 1, right? Let me change my color real quick. How about c? For c, I got z to the 1 over 4 power, right? What does that become? Index of 4, z to the 1 power, right? And that's it. It's a radical, yeah. Yeah, always. Any other questions, or this makes sense? All right. Go ahead, you guys try. All right, let's take a look. What's A? Good. What about B? Hold up 1 second. Yeah, what's B? Uh-huh. Very good. How about C? Mm-hmm. Good. Questions on this? Which one? Oh, for the first one? So without the two is the same thing as a square root. Yeah. So, but I leave that up to you. If you want to write the two, go ahead. If you don't want to, it means the same thing. Yeah. Yeah. Whenever you don't see anything there, that's a square root. Right? Any other index power will have a number there. So I want to do the reverse over here. All right, going in reverse now. So I have A is the square root of 5 to the y, oh, excuse me, square root of 5y, right? What's the answer for this? Open parentheses, 5y raised to the 1 over 2 power, right? Let's try B. That's it. So for B, so that you see that it's underneath everything. Yeah, like it's inclusive. In B, I have the cube root, 4x. What's my answer? Open parentheses, 4x raised to the 1 over 3 power. Right? How about C? I have 3 4th root and 5z. What does that become? 3, open parentheses, 5z raised to the 1 over 4 power. Right? Any questions so far? We're going in reverse now. Yeah. Right. It's under both things. Yeah. Got you. So you guys try. Go ahead, you guys try. Let me know who's the friend. All right. Let's see. The library over here been feeling good though, man. It's not too cold. It's not too hot. Yeah. So fairly recently, like as recently as last semester, right? I don't know why this is, but half of the library had AC. This was the AC half. Other half of the library had nothing. So in the summertime, those rooms on the other end were blazing, blazing. And then our rooms were freezing. Like if you didn't have a jacket, you were screwed. Like I don't care if it was 100 degrees outside, like you were screwed being in here. So we had to like keep the doors open. And then on the other end though, it was a sweat box. Like yeah. Yeah. But I guess they fixed the AC because it's been hot in here. It's not too bad. Oh, before you came in, I was telling everybody that today was pantry. I was hoping they all y'all went and got it. Okay. Got another pantry in 2 weeks. Yeah. There's two that's gonna go down in August also. One of them is, nah, both of them, ain't nobody gonna be here but them. So you'd have to literally just come to campus and pick up free groceries and that's it, kind of thing. And then September, of course, there'll be probably two more. But September is gonna be like bigger, because right now it's summertime, so they do like 1 day, kind of thing. But in the semester, it's 2 days. It's like a Wednesday and a Thursday. All right, let's take a look at this, right? So I'm gonna do A. So I have square root of 10m. How do I change that into a rational exponent? Uh-huh. Right? 10 to the 1/2 power. Very good. How about B? Hold on 1 second. I'm gonna go with the BCC green. All right, so I have the fifth root of 3n. What's the answer? Uh-huh. 1/5 power. Perfect. Perfect, perfect, perfect. And then I'm gonna go blue. No, no, let me go purple. All right, how about C? I have the fourth root of 6y. What's that gonna be? Mm-hmm. You're 1/4 power. Good, good. Oh, I'm blind. I didn't even see that. Thank you, thank you. All right, outside 3. All right, any questions so far? You good? You know what though? I'm looking at that outside 3, like it don't look like it's that easy. Hold up. I'm looking at that. Something funny looks about that 3. About C. Yeah. Here's what I'm thinking it is though, right? Whenever we do these, right? I'm always looking for the perfect whatever to simplify down or whatever. Answer C looks like a simplified version of an answer to me. It's my fault. I know I didn't mention this before, but I feel like what this should be, right? Actually, wait, no, 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 that's right. No, no, that's right. Because that's what we're just switching them around. I was gonna go a little too far with that. My fault, my fault. That's the next section. I'm jumping the gun. I'm jumping the gun. All right, this is what I was thinking about. My fault. I'm jumping the gun a little bit. All right, let's say I have something like this, right? I got 25 to the half power, right? What does that mean again? Somebody help me out. Right, 25 to the half power means square root of 25. And the square root of 25 is what? It's 5, right? Bam. So that's what these fraction exponents mean, right? Let's try out B real quick. So I got 64 to the 1/3 power. What does that mean? Cube root of 64, right? Which is equal to what? Close. Give me something better. 4, right? So 4 times 4 times 4, 64. Yeah. I'm gonna do this in pink, all right? So let's say C, right? I have 256 raised to 1/4 power. What is that? Okay, so fourth root of 256, good. Which is what? 4? Okay. So 4, right? Ooh, I see a lot of smiles walking outside. Okay, good for them. They had a test today. All right. So you guys try. I'll leave up 1, like the last one. Yeah. Yeah. No problem. Just watch the recording and do the homework. Not square root, the fourth root of 256 is 4. Yeah. So if you take like 4, yeah, like that. Yeah. All right, we good? All right, let's take a look at A. So I have 36 to the half power. What is that? 6, right? Or square root 36, right? How about B? Help me out. I have 8 to the 1/3 power. What is that? 2, very good. Right? Because that's the cube root of 8. How about, we'll do orange. How about C? I have 16 to the 1/4 power. What is that? 2, right? Because that's the fourth root of 16. All right. Questions? Do which one? Like a process to it? So they're telling me the answer, so I'm just writing them down. But to show you where it comes from, that's why I do it on the side here. Yeah. So that's the secret. All right. So I just want to emphasize something real quick before we continue. All right. So be careful of the placement of the negative signs in the next example. We'll need to use the property A to the negative n power is equal to 1 over A to the n power in one case. All right. So let's take a look. So let's say I have negative 16 raised to the negative 1/4 power, right? What's that? Is it? Let's take a look at that. Negative 16 raised to the 1/4 power. We know is the same as the fourth root of -16. So what's the answer? Not 2. What's the answer? Nope. What's the answer? Nope. What's the answer? Hmm? What's the answer? What is it? No, no, not 4 squared. Not real. Now we're talking. That's the answer.
Because of the negative.
Right. You know, because of the negative, right? And we have an even index, right? Then we'd be good to go. Yeah. It would be 2 and then cube root of 2 if it was cubed. Yeah. So basically, because the right, any even index, if it's a negative underneath it in the radicand, not real. All right. How about B? I have -16 to the 1/4. What is that? -2. Now we're talking, right? So that's going to be -4th root of 16, right? And then that's -2. All right. Go ahead. Mm-hmm. Mm-hmm. Right. Because it's outside of the parentheses. Right. It stays outside. Yeah. How about C? So this one is 16 raised to the -1/4 power. What's that? Mhm. So what do I do with a negative exponent? Fraction, right? So what is it? Right. So 1/16 to the 1/4 power, which becomes 1 over the fourth root of 16, which is what? 2, right? So this is just 1/2. All right. Questions on this? Make sense? Okay. Because the radicand is negative and the index is even. Yeah, so anytime we have an even index with a negative radicand, it's not a real answer. Doesn't mean it's not an answer. We just haven't talked about that yet. Go ahead. Yeah. Yeah. So anytime you have a negative exponent, you drop it down into the denominator and make it positive, right? Yeah. Yeah. Right. All right, you guys try. Same question, but easier. Mhm. Which one? No, they're not. They're different. Yeah. They look the same, but they're not. All right, let's take a look. So what do we have for A? My man, that's what I'm talking about. Not real. How about B? Hold on one second. How about B? Negative what? -8. Good. Mm-hmm. How about C? Very good. Questions on that? Anyone? There you go. 1/4? No, square root. So two numbers that multiply to give me 64. Yeah. What did you say? Yeah. Yeah. All right. So now that we're done warming up, let's take a look at the real thing. So I want to simplify expressions, right? With a to the m over n power. So we can look at a to the m over n power in two ways. Remember, the power property tells us to multiply the exponents so that a to the 1 over n raised to the m power and a to the m power raised to the 1 over n power both equal a to the m over n power. If we write these expressions in radical form, we get a to the m over n is equal to a to the 1 over n raised to the m power, which is equal to the nth root of a raised to the m power. Or we could say a to the m over n power is equal to a to the m raised to the 1 over n power, which is the nth root of a to the m. Both are the same, right? The reason why this is because remember how when we raise the power to a power, we multiply, right? 2 times 3 is the same thing as 3 times 2. So we can interchange them here, right? Interchanging them is going to help us in the future. Make sense? Yeah, I need to hear it again. I got you. Here you go. You already know. All right. So rational exponent a to the m over n. So for any positive integers, m and n, a to the m over n power is equal to the nth root of a raised to the m power, and a to the m over n power is equal to the nth root of a to the m power. All right. Hmm? Not getting it? All right, all right, let's do it one more. Let's do it one more time. Let's do it one more time. All right. So, which form do we use to simplify an expression? We usually take the root first. That way, keep the numbers in the radicand smaller before raising it to the power indicated. All right. So that's the hint. Before we even get too deep into that, right? Let's do this example. Nothing crazy. So I want to write a rational exponent. All right. So let's say A. I have the square root of y to the third power, right? So I want to write this, right, as a rational exponent, meaning a fraction power, right? This is going to be what? Y to the 3 over 2 power. Hmm? Questions on that? All right. So the power that's on the radicand, that's your numerator, and the root, that's your denominator. Right, right. Or the index, whatever, right? Let's look at B. This is the cube root of 2x raised to the 4th power. What's this going to become? Okay, so 2x raised to what power? Close. Hmm. All right, it's actually 4 over 3. The index is always the denominator, right? And the numerator, right? The numerator is the power that's on the outside. Yeah. All right, let's try it again. So now I'm looking at C. I have the square root of 3a over, oh, that's 4b. Whoops, made a mistake. 4b raised to the 3rd power. What does that become? Okay, so I heard 3a over 4b raised to what power? 3 over 2. Very good. My index is 2. The power I'm raising to is 3, so 3 over 2. All right? You guys try. All right. What's the answer for A? Very good. Let me change my color real quick. What's the answer for B? 3y, parentheses, right? 3y. And what is it? Very good. How about C? I over 2. Questions on this? Yeah, yeah, yeah. What? Ask me. Gotcha. Yeah, so no number is a square root, so it's 2. All right. So real quick, just want to remind y'all. All right. So remember that a to the negative n power is equal to 1 over a to the n. The negative sign in the exponent does not change the sign of the expression. All right. Negative sign of the exponent does not change the sign of the expression. All right, let's take a look at this. So I got 125 to the 2 over 3 power. What's that? Hmm? Say it again. Good. So cube root of 125 to the second power. That's exactly how I would do it. And then the cube root of 125 is what? 5. Good. And then 5 to the second power is what? 25. And that's it. All right. So moral of the story. No, 25. Mhm. So moral of the story, do the root first and then raise it to the power. So let's look at 16 to the negative 3 over 2 power. What does that become? Very good. 1 over 16 to the 3 over 2 power, which becomes what? Very good. The square root of 16 raised to the third power, which becomes 1 over, what's this, 4 to the third power? And what's 4 to the third power? So 1 over 64. This is your final answer. All right. So for C, I have 32, negative 2 over 5. What's going to happen to that? Hmm? Say it again. All right. 1 over 32 to the 2 over 5, which equals what? Hmm? So 1 over the fifth root of 32 raised to the second power, which is equal to what? 2. Good. All right. Ooh, hold up. There we go. All right, and then this is final answer is what? Four, right? Questions? This make sense? So the fifth root of 32, right, is 2, right? So let me see. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2, 32, yeah. Mhm. So I don't. I know how to count. That's my trick. Yeah. And then 2 to the second, that's 4. So, to the 5. So 32 to the fifth root is 2. So if you take 2 times 2 times 2 times 2 times 2, right? Like 5 twos, you get that. You guys try. right? Looks about good. Let's give this a try. How about A? What we got? So is it 9? Hold on. Mhm. So for A, 27 to the 2/3 power, this becomes the cube root of 27 squared. And the cube root of 27 is 3, right? So 3 squared is 9. So that'll be my final answer, right? How about B? 81 -3/2. Square root first. Well, actually, no. Negative first. 1/81 square root raised to the third power. What do I have? 9 to the third power, which is what? Trust you for that. Yeah. So now I have 16 to the -3/4. What does that become? Mm-hmm. What's the answer? Which is good. Questions? Make sense? Um, real quick, just to make me feel good that we're really, really getting this and we're not just making it up. Let's do these three real quick. So for A, I have -25 to the 3/2 power, which becomes what? Negative square root 25, right? Raised to the third power, right? So this is -5 to the third, which is equal to what? Uh, it's the cube of 5. This is -125. Any questions on that, or it makes sense? All right. B, -25, -3/2. What does that become? That, yeah. So this is what? So 1/5 to the third, which is what? 1/125. All right, how about C? Help me out with C. Now we're talking. Right? So remember what this is becoming now, right? This is gonna become -25 square root and then cube, right? Right, so that's why it's not real. We have a negative radicand, and our power is even. Sure, got you. Right, right. Let's take a look. How are we looking at A? Oh. So I heard a negative, what's it, square root of 16 cubes? This becomes a negative, what is it? Not 8, what is it? 4 cubed. which is what, negative 64? Really? Yeah, it is 64. You're right. My fault. Let's go B. Okay, good. What does that become? Oh, wait, 1 over. Forgot about that. This is square root of 14. I mean 16. 4, right? To the third. This is what? 1 over. It's good. And C. Questions on that? Mhm. So in the first and second, negatives on the outside, right? So just the way they worded the question. So you just bring it back in the answer at the end. Yeah. Oh, so negatives on the outside for B, right? No, C. Yeah. B not real. Yeah. Yeah. All right, next we're going to use the properties of exponents to simplify expressions with rational exponents. The same property of exponents that we have already used also apply to rational exponents. We will list the properties of exponents here to have them for reference as we simplify expressions. All right, so here you go. You guys can copy that down. Whatever you want. No pressure. All right. While they're copying that down. Oh. Yeah, while you copying that down, if you want to try a question, go ahead. Y'all give that a try. Same properties that we went over before, product property, raise power to power. When you divide, right, the exponents, you subtract their powers. Same old. This time the m and the n are rational exponents. All right, let's take a look. So for A, right? I'm multiplying these powers. So what am I going to do with them? Add them, exactly, right? This becomes x to the 1 over 2 plus 5 over 6, right? LCD over here we know is 3, excuse me, 6. So I'm going to multiply this 2 by 3. What I do to the bottom, do to the top. So what does this become? This becomes x to the 3 plus 5 over 6, which is x to the what? Is that 8 over 6? Right about that? Reduce that a little bit. This becomes x to the what? 4 over 3? Questions on that? All right, let's take a look at B. Uh-huh. Right, because we're multiplying them, right? Now look at B. B, I have z to the 9th power, and I'm raising that to the 2 over 3 power. So whenever I raise a power to a power, I multiply, right? So what does this become? Z to the 9 over 1 times 2 over 3, right? Y'all know I'm not too good at the multiplication, so I'm gonna do some tricks. 3 goes into 3 once, 3 goes into 9 3 times. So what does this become? Z to the 3 times 2 power, which is z to the 6, right? Yeah. All right, let's take a look at C now, right? All right, bear with me a sec real quick. I'm just gonna copy this down here for because it's gonna cut off. All right, whenever I'm dividing exponents, what do I do? Not yet. Subtract the powers, right? So what does this become? X to the 1 over 3 minus 5 over 3, right? Now 1 over 3 minus 5 over 3 becomes negative 4 over 3, right? And then what happens to the negative exponent? Goes down to the denominator, right? So this is 1 over x to the 4 over 3 power. Questions on this? Sure. So we just taking all those exponent rules that we already know, we're applying it to this. The only difference is that now we have fractions. Go ahead. Because whenever I divide exponents, I subtract their powers. When they have the same base, right? And they have two different powers, I subtract the powers, top minus bottom. I would still subtract it, yeah. Yeah. So this is kind of just putting everything together. You guys try. All right, let's take a look. So for A, right? I have X to the 1/6 times X to the 4/3. What do I do? So I'm multiplying, right? So what am I gonna do to the powers? Add them, right? So that's 1/6 plus 4/3. But in order for me to add those, I gotta have the same denominator. So multiply this by 2, right? 6. I do to one side, do to the other. Excuse me, what I do to the bottom, I do to the top, I meant to say. So this becomes x to the 1/6 plus, what's that, 8/6? Which is x to the 9/6. Questions on that? Oh yeah, we should reduce it, you're right. So this becomes x to the what? 3/2? Yeah, that sounds better. You're right. All right, let's look at B. So for B, I have x to the 6th power raised to the 4/3 power. And whenever I raise a power to a power, what do I do? Huh? Not add. Multiply, right? So this becomes x to the 6/1 times 4/3, right? Now you already know I'm going to do some tricky stuff right here. 3 goes into 3 once, 3 goes into 6 2 times. So this becomes what? X to the 2 times 4 power, or x to the 8th power? Questions on that? So whenever we have a power to a power, we multiply, right? All right, bear with me 1 second real quick. I want to do C, but it's going to cut off, so I just want to copy it down real quick. So I got x to the 2/3 divided by x to the 5/3. Okay, whenever I divide exponents, what do I do to the powers? Subtract, right? So this becomes x to the 2/3 minus, top minus bottom, 5/3. And it helped me out. 2/3 minus 5/3 is close. -3/3, right? Which becomes x to the -1 power, right? And remember, it's illegal for me to have negative exponents. So what happens to this? Flip it, right? It becomes 1/x to the +1 power, or you could just leave it as 1/x. All right? Hmm? You divide it, yeah, 3 divided by 3, so just 1. Yeah. Yeah. All right. Make sense? Awesome. All right, now that we got that out the way, right? Time to just put everything together, right? So sometimes we need to use more than one property, right? The next example, we will use both the product to a power property and then the power property, all right? So peep this, peep this. It's about to be real right now. Damn, right? So I'm looking at A now, right? I got 27 u to the half power raised to the 2/3 power, right? Yikes. But it's all right though. We already know what to do, right? We just gotta do it piece by piece, right? Piece by piece. So you want to start with the outside, right? I'm doing A, right? You want to start with the outside. So the 27 u to the half power raised to the 2/3 power, right? Remember, I want to take that outside power and put it on everybody inside of that term. Everybody gets the 2/3, right? How Oprah would do it. You get a 2/3. You get a 2/3. Everybody gets a 2/3, right? So we have u to the half and a 2/3, just like that. All right. Now, solve it, right? Now we can solve it, right? So for the 27, you already know that's going to be what? Cube root of 27, and then we're going to square that, right? And then keep it going. It's 3, right? So this becomes 3 squared, which is just what? That's 9. All right. Not too bad, not too bad. Let's look at the second part here. So I have u to the half raised to the 2/3 power. What am I gonna do? When I raise a power to a power, I multiply, right? So this is u to the half power times 2/3, right? Y'all know I'm not too good at multiplication, so I gotta do some tricky stuff. 2 goes into 2 once, 2 goes into 2 once. So this becomes what? U to the 1/3 power. Just like that. So we have u to the 1/3 power next to the 9. Boom, that's the answer. That's it. Questions on that? Let me zoom out a little bit so you can see all of that. This is putting everything together, right? This is the meat and potatoes right here. All right, let's zoom in out so y'all can see that one real quick. And let me know when y'all finish copying. All right, bet. All right, this is getting a little complicated for me, so I'm just gonna cut and paste this real quick. Give me 1 second. Damn. All right. We're just gonna cut and paste this right here for part B. This one got a little bit complicated over here. I'm gonna make this a little bit smaller. Everybody can still see that, all right? No problem? All right. I'm gonna change up my color. Let's go rainbow for this one, all right? So I have m to the 2/3 power times n to the half power raised to the 3/2 power, right? So same thing as before, right? We're gonna deal with the outside first, then we're gonna deal with the inside. All right. So we're gonna raise, everybody's gonna get that 3/2 power. Everybody. So I got the m to the 2/3. I'm gonna raise that to the 3/2 power times, right? I got the n to the 1/2 power. I'm gonna raise that to the 3/2 power. Did I lose anybody? All right. So now look, whenever I raise a power to a power, I multiply, right? So this is going to become what? M to the 2/3 times 3/2. Oh, Lord, here we go. Now it's not writing. Really? All right, 3 over. Yo, for real? Are you gonna do me like that, Microsoft? Oh my gosh. It's too many colors, is that it? It's because of the colors? Oh Lord, for real, you gonna do me like that? Microsoft is gonna shut it down like yo, that's too much. I'm gonna bring it back though. I'm gonna bring it back. Don't worry, I got y'all. I'm gonna bring it back. Microsoft just did me dirty just now, man. Yeah. It's too many colors, maybe. That's what it's telling me. Like I'm walling on the colors. But I need the colors though. That's how we understand, you know? All right, so look, I got the 2/3, right? Times the 3. Hold up. Now you done took my colors away. It's like that. And you really don't want me to? Come on. Now we talking 3/2. Oh dang! Come on. There we go. There we go. There we go. There we go. We good. We good. Times we got the n to the 1/2 power, and then whenever you raise the power to a power, you multiply times the 3/2. Just multiply straight across. Nothing crazy over here, right? I'm gonna do some tricky stuff because I'm not that good at multiplication like y'all. So 2 goes into 2 once, 2 goes into 2 once, 3 goes into 3 once, 3 goes into 3 once. So this becomes what? M to the 1/1 power, or just 1, times n. Over here, I'm just gonna multiply straight across. 1 times 3, what's that? 3, 2 times 2, 4, right? So final answer, scroll down a little bit. I'm gonna have M, right? Times n to the 3/4 power, just like that. Questions on that? I'm gonna zoom out a little bit so we can take a look at that. Boom. Go ahead. Yeah, you for the M, there's an imaginary 1 right on top of it. Yeah. Yeah, it would be on top there. Yeah. No. Yeah. Also, I can't put them in parentheses either because the M doesn't have the 3/4, right? It's just the N that got it, right? So I have to leave them separate like that. Right. Yeah. Mhm. Not too bad, not too bad. All right, I see that's time real quick. All right, before we go, I just want to show you like something crazy real quick. This will be like the last problem. Unfortunately, I'm not gonna give y'all a chance to try that one because of time, but let me just show you this crazy one real quick, and then we could call it at that, right? Just watch the recording. You know, if you need to refresh on this, then you can take a look. All right. So here we go. Let's look at A real quick. I'm gonna do this in a solid color. No, I don't like black. All right, I'm gonna do this in BCC green. All right. So look, for A, right? I have X to the 3/4 power times X to the -1/4 power divided by X to the -6/4 power. Yikes, right? Let's just have a quick conversation. What should not be my first approach here? What should I do first? Before that, okay? I should simplify the numerator, right? The top part, right? So that being said, right? I'm gonna have X up top, right? Whenever I multiply exponents, what do I do again? Add them, right? So this is gonna become what? 3/4 plus -1/4. All divided by, of course, the X to the -6/4 power, right? So whenever I add the exponents, I have to have the same denominator. In this case, I do. So 3 plus -1 is what? All right, so this is X to the 2/4 all over X to the -6/4, right? All right, so now, all right, let me just go across real quick. Just go across real quick. Whenever I'm dividing exponents, right, what do I do with the powers? Subtract, right? Top minus bottom. So this is going to become what? X to the 2/4 minus -6/4. All right. So somebody help me out. We got the same denominator here. So this is going to become what? X to the 2 minus -6 all over 4. Help me out. 2 minus -6. What's that? is 8, right? So this is x to the 8 over 4, which becomes x to the 2 power. All right? Questions on that? I know that was a little crazy. Yeah, I know I want to do B. B is that real deal. I got you. I'll do that right now. I'm really sad to report I couldn't find a question as hard as A and B here for your homework. Sorry about that. Homework is a little easy. I'm gonna try and make that up to you on the next test though. All right. All right. Let's take a look at B real quick. All right. Trying to rush a little quickly because of the time. I know time has passed. This will be the last example. I got you. So for B, this it's big. I'm gonna just make this a little bit smaller. This will be easier to write. Everybody can still see this? No problem? All right. So real quick, right? For B, check this out. So I have 16, right? Times x to the 4 over 3 times y to the negative 5 over 6 divided by x to the negative 2 over 3 power, y to the 1 over 6 power, right? All right. What I want to do is I want to simplify the inside, right? I'm going to simplify the inside of the parentheses first, and then I'm going to put the powers on everybody, right? Just to make it a little bit simpler. So check this out, right? 16 is already simplified, so nothing to do there, right? How about the x's though? Right? When I divide the x's, what do I do to the powers again? Subtract, right? So this is going to be top minus bottom. 4 over 3 minus negative 2 over 3. I'm going to do the same thing with the y, right? Top minus bottom, right? This is going to be negative 5 over 6 minus 1 over 6, right? And then, of course, all of that is raised to the half power. Let's finish simplifying that. It's going to become what? 16 x to the, let me see, a negative times a negative is positive. What's that, 8 over 3? No, 6 over 3. Ooh, nobody even said nothing. Okay. All right, I understand. Y'all tired. I get it. Okay. Yeah, so, no, we're adding, or, yeah, because negative and negative is positive, so 4 plus 2, 6. Yeah. Over here, we have negative 5 over 6 minus 1 over 6. This is what? Negative 6 over 6, right? Raise that to the half power. Let's make our lives a little bit easier. Let's reduce these. So this is going to become what? 16 x to the second, y to the negative 1 power. All of that raised to the half power. Now again, everybody inside that parentheses right there in that term is getting the half power. Everybody. So we got 16 to the half power, right? We got open parentheses x squared to the half power, and we got open parentheses y to the negative 1 to the half power. Everybody's getting it, right? So 16 to the half power is what? Remember, 16 to the half power is the same thing as what? Square root 16. What's that? So that's 4, right? And then now, when I raise a power to a power, what do? Multiply, right? So this has become x to the 2 over 1 times 1 over 2. 2 goes into 2, 1. 2 goes into 2 ones right here. So you already know what that's going to be. Y over here, this is negative 1 over 1 times 1 over 2, right? Going straight across, what do we have? We're going to have 4 x to the 1 power, and then y to the negative 1 over 2 power. But remember though, it's illegal for me to have negative exponents, right? So what's gonna happen here? It's gonna become 4 times x over y to the half power, right? Dang, we have another issue too. Another issue. We ain't talk about this today, but we're gonna get into this next class. It's illegal for me to have radicals in my denominator, right? Illegal for me to have radicals in my denominator, right? So that being said, right? Another way to write this is like 4x over the square root of y, right? So now I gotta rationalize my denominator. So how do I rationalize my denominator? Just multiply this by the same denominator, radical y and radical y. Just like that, right? Multiply straight across. Here's what the final answer is going to look like. 4x square root of y over. Now, square root of y times square root of y is what? Square root of y squared, right? These will cancel, right? So this is the final answer. 4x square root y over y. Huh? Yeah. So this would be it. Yeah, I got you. So yeah, tomorrow we're gonna get into that, right? It's illegal for us to have radicals in our denominator. In our case, though, right? We were dealing with half powers and all of that, right? So it's illegal for us to have rational exponents in our denominator. Yeah? And then we just have to rationalize it and boom, we're good to go. Bless you, bless you. All right. Leave that up in case anybody needs to copy. Have a good night. All right.
Oh, good, man.
Gotcha. Wait, hold on one second. Hold on one second. It was insane. Don't worry, you ain't gonna see a question like that. The last question was for my entertainment. Yeah. But before I close out the recording, I just wanted to put these properties back up one last time. So when you guys are watching the recording, you can reference them as needed, right? Product property, when you multiplying the powers, you add them. Power property, when you raise power to a power, you multiply. Product to a power, right? Everybody inside the term gets that power. Quotient property, right? When you divide exponents, you subtract the powers. Zero exponent definition, anything to the zero power is 1. Quotient to a power property, everybody inside of the rational expression gets the power. And a negative exponent property, which is something that we went over today. Anytime you have a base to a negative exponent, it goes into the denominator, right? And then it's going to be just a to the n. All right, that's it. Have a good night, everybody. I'm going to end the recording.